So my talk is implementing bulletproof access control within Kubernetes. Now, RBAC is a very difficult thing for people to first get into, because when you go to the documentation page, you get immediately overwhelmed, and I've certainly been there before, so I want to be able to teach you guys how to use RBAC effectively, and by the end of this talk, you should easily be able to create your own roles. So what is RBAC? Basically, RBAC is role-based access control. It's basically regulating access to a computer or network resources based on roles. It was, in 2000, it was standardized, and it goes back all the way until 1992. So within RBAC, within Kubernetes, it is purely additive, as in you give it allow permissions, and that's what it does. You have roles and role bindings, which are namespace isolated. It checks to see if they are authenticated. If they are not, it fails. And then it takes the request attributes and sends that to the authorization auth-z. And then they'll basically see if the RBAC configurations allow it or deny it. But then, of course, it goes on to the admission controllers. So this is assigning roles to subjects within EKS itself. I sort of wanted to get a simplified way in which you can add your users within AWS itself to access to your Kubernetes cluster. So why EKS? I mean, why use that in particular? So essentially, it just allows for automated control plane management. You create a cluster on the fly. It's extremely simple, and they do security patching for you. If you've managed a control plane, it can be quite a pain, so it's nice to be able to click a button. And basically, compatibility with existing, and obviously support. At Tinder, we're a very large organization, and we run into things that nobody else will run into, so that support is invaluable. So basically, implementing RBAC with IAM roles. So within most large organizations, you'll have federated access to role assumption within AWS. So you'd implement it with Okta or some sort of single sign-on solution that you have. And essentially, this is how we would do so at scale, which is essentially that, of course, you would have a CI/CD pipeline to be able to deploy your resources at scale. So obviously, you want to organize it in a way that you can deploy users easily, simply, and that people can understand. So in this example, it's basically the AWS IAM Authenticator allows you to actually access the cluster and authenticate to the cluster. You basically utilize existing federated access. And then essentially your structure for your CI/CD deployment, you would have essentially an access folder within your repository that normally contains your Helm charts or whatever you use to deploy. And then you would essentially split it out into different groups within your organization that you'd normally have with role-based access control. And so essentially in this case, we just have like a developer, operations team, and the security team, and we split them up into 3 different aspects. So then let's go over an actual example. So in this case, I'm creating a role. And in this situation, I'm creating the Tinder dev, and I'm allowing it to be able to get, list, watch on the resources pods, deployments, and config maps. And then once you've created your role, you go straight to a role binding so that you can bind the role to the particular subject. So in this case, you see the role ref, Tinder dev, and you see the subject, Tinder dev, and you're essentially, once you apply that, it performs the role binding. And then with AWS Auth, all you need to do is be able to authorize the role to be able to authenticate to your Kubernetes cluster. So in this case, it would be similar in others, but essentially you created the role binding, and then you essentially configured it for that role to be able to authenticate. And as you can see in the little structured folders that we had earlier, if you just define those at large in each auth.yaml file, you can be able to do so. And this is just it as a whole, put all together, so that you can authenticate and provide role-based access control through a CI/CD environment, so that it doesn't have to scare you so much. So you also have default user-facing roles. So let's say you're a little scared and you don't want to go ahead and create them right now. Well, I mean, they set you up for success to utilize it. So you have the cluster admin, which, please don't give that to everybody. You have admin, edit, and view. So you can, and these are cluster role bindings as well. But essentially, yeah, gives you a very simple way and an example that you can use. So now I'm going to go into some advanced RBAC configuration. Now that you sort of dip your toes into it, now I'm going to drop you in. So essentially now, if you want to, so you know now that a role binding is isolated on a namespace basis. And you know that a cluster role binding is across all. So what happens if you only want to grant access to 3 different ones? Well, what you would do in this case is you can define a cluster role and use a role binding to bind it to the subject. You can also use resource names to grant access to specific resources within your cluster as well. You would use multiple rules in which you do so when you granted access to verbs. Because if you go back to an example, those are the individual, I should go back. So here you can see the rules there. You can create multiple of them, and it's best to split it out so that you can see exactly what you're granting and sort of make it easier for humans to read. So then you have non-resource URLs, which provides you the ability to be able to restrict requests to the non-resource endpoint. And here's an example of non-resource URLs for you over there. And this is just sort of an example right there. So then I'm going to go into RBAC best practices, sort of what you should do when you start getting into RBAC. So first of all, RBAC is principle of least privilege. Make sure that you only grant the developers what they need access to. Make sure you only grant your operations team what they need access to. And security is always God mode for the most part. So then RBAC is the standard. Enable it. Essentially, if you're using an older Kubernetes version, like 1.7 and below, you should be up there already, and you should be using RBAC. It is the standard. If you are not familiar with it, I strongly recommend just start getting your feet wet. And then also disable auto-mounting of the default service account token so that not all pods need to be able to access the API server. So why should you grant it that access by default? I will also say that with kube to IAM, one of the default things that it does when you spin up, say, an EKS cluster, is that pod, if you don't assign it a kube to IAM role, it'll give it, by default, the role that the worker node is running, which is normally star and star. So it's very important that you look into these default configurations because you can trip up. Because that way you go, oh, I think I gave it no permissions, but in reality you gave it as high of a permission set as you can give it. So then also you should use dedicated service accounts. This grows across every platform and every federation platform available. Just make sure that everything is dedicated to the particular application so that if you do scale overnight, it shouldn't be that difficult for you to be able to do so, and you don't have crossover for revocation processes, etc. So then also avoid the use of wildcards. If you're using it, you're probably doing it wrong. You should be able to just get a list of the verbs, do so, put it in place by place. Make sure that you just don't put star. And that should always be something that should trigger in your head. Every time you see that, you should be going, whoa, that's not configured correctly. Do they really need access to all of the verbs? And then also, here it is an example of Tiller. So as you can see right here, maybe a little small, but essentially it's a cluster role and cluster admin. Obviously, that's very, very bad because it has access to all of the different namespaces and allows for you to be able to have admin across the entire cluster. So maybe isolating that across namespaces will be better. But just to give you an example of some things that you may be aware of. So then what are some tools surrounding this to sort of help you out a little bit? Well, I can tell you that we use Aqua, and it provides us the ability to very easily manage roles within an interface, but it also has direct integrations with your pipeline as well. Pretty much everybody at a certain scale goes to a CI/CD pipeline in which they automatically provision resources. So it's very important to stay up to date. Security teams are often one step behind the operations team. So it's very important that you integrate as early as possible. And then also there is a tool called RBAC Manager, which allows you to very easily create RBAC sort of files for you to define them, and allows a very simple way for you to see between a user and what permissions they have. Because as you saw in that one example where we put everything together, it gets quite large, hard to manage a little bit, but it's a very nice tool. And then audit to RBAC allows you to be able to view the Kubernetes audit logs and determine what RBAC permissions that these individuals should have. Like, let's say that you have a large group of developers and they come to you and say, I need access to everything. Well, of course they'll say that. You don't want to provide that level of access. So what you do is, okay, so maybe you give them that level of access within that namespace. After a month, determine what they've accessed in the audit logs, and then lock them down based off of that. So you've provided them the full flexibility to do whatever they want for an extended period of time, and then you cut them off based on what level of access they really should have. So yeah, essentially, yeah. By the way, gotinder.com/jobs. We are certainly hiring. And does anybody have any questions?
Okay, yeah, let's go ahead and take questions. First, thank you very much, Johnny.
Thank you very much.
You got a question back here?
Yeah, for the EKS AWS authentication config map, do you automate that portion of the configuration? Because that's slightly different than the standard YAML policies for role bindings and cluster roles.
So are you saying that we basically automate the processes within AWS Auth to provision?
When you provision the AWS IAM roles to EKS, do you automate that?
Oh, absolutely. You should have a CI/CD pipeline everywhere, preferably, and you should have IAM roles based on groups within your organization. So creating roles and automating the auditing of those processes is very important. I constantly have a list of existing roles within AWS that humans can assume, and I audit them on a regular basis, as well as be able to deploy them very easily. But yes.
Great. More questions? Yep, back here.
Hi, thanks. First of all, thank you for making Tinder.
It wasn't me, but thanks.
If you have problems in production, do you find it difficult for the developers to debug it without getting too many permissions?
I definitely see that. Well, that is why you should use something like the tool that I mentioned earlier, just because of the fact that it gives you the ability to make sure that all of the developers have had enough time to enumerate all of the permissions and have done so. Yes, restricting too many permissions ends up being worse, because then they'll push you to grant far more access than they ever need. So it's important that you're open and flexible from the start, but then once they've sort of homed in what permissions they need, you lock it down as best you can. But it's always a battle.
Couple more questions? Come on, here. All right. Thank you again, Johnny.
All right, thank you.